Hi, I'm Jane, if you don't know who I am. I want to thank everybody for all the fun things they did during the day, and I hope you have a wonderful night tonight. The whole purpose of this event, my husband and I, is to honor memories and save lives. Now, I'm going to steer away a little bit to tell you that those of you who know that I've not been well for about 6 weeks, I put my husband to the test. We didn't get divorced. He almost learned how to fill the dishwasher. And he knows how now to take the wash from the washing machine to the dryer. And what that taught me is that we can do anything with repetition. So on that little note, I do want to say that my husband is an amazing man who has the respect of the community, who I could not have done, especially this year, the event, without him. And after 56 years, we're still together. I would like to acknowledge some other person here, a dear friend of mine, Kathy Patterson, who I don't know over the years, although it's been here, her montage, which is behind me, is just amazing. Very nostalgic, very sad, very beautiful. And I want her to know that I got the biggest screen I could this year behind me, so that you all have a great view and ample opportunity to see her creativeness. Thank you, Kathy. Well, I also have to say, I have a lot of other people to thank. First of all, my little elves who worked very hard on this event during the week, handing out t-shirts, tonight doing the name tags, helping wherever I need, whatever I needed to do. And then of course that would be Lana and Patty and Wendy and Maureen and Tina, so it's a myriad of people. And of course, we would not have this event if it wasn't for the kind of staff we have here. And chef, and sous chef, and pastry chef, and all the people who are working tonight. I truly thank you from the bottom of my heart. Of course, one of my most favorite people, in addition, is Doug Davis, who is our IT man, who makes sure we have no hiccups during the evening. And he has done this for an enormous amount of time for me, I think almost all 11 years. We're here 11 years this year, our lucky 11. And it is, as you will hear, a lucky 11. And I think he's always reduced his bill because it's a cancer fundraiser, and I do respect him very much. Also, we have our DJ who always reduces his bill for charity. So I want you to know how many wonderful people are involved in this event. I feel Selfish is my extended family. Our son Keith called it a paradise, and a paradise it is. The people that we have met over the years makes this place very, very special. He got married here, had his wedding prior to marriage here, came every opportunity he could, and I know he's with me tonight. There are other people, I'm sure, that I forgot, but I do have, they call long-term COVID memory loss. But you'll have to just forgive me. What else can I tell you? On your table, each of you have a candle to light. Mine is lit for my son always. You have the ability to light your own for whomever you want to remember or mortalize. And of course, this really is a big event, and the glue that holds this place together is Bryce. And I think he deserves it. I think that you have to understand how you are so important in this event, because Dick and I may be a spark, but you guys, you're really the fire. And without you, there would be nothing. And you will hear later on how many advances and how generous you all are. And I sincerely mean that. You are the fire. Now, I'm going to end with an upbeat thing, because, you know, we're here, we recognize our loved ones. We are going to watch, as evening progresses, all of Kathy's hard work all night long. And I do hope you appreciate it and watch it. And then we're going to celebrate, because we're going to celebrate what we have accomplished. And it's no small thing what we've accomplished. You know, I love Sailfish, as does my husband. We'll always be here for anything we can do for anyone. And I'm going to end in an upbeat way. It's a tough night for me. And that is to play a song as my husband and I go about the room to personally thank you. So just bear with me, just the length of the song, and thank you.
This me. I need the bell again. Good afternoon, and thank everyone for coming and supporting us and CRI. By now you know I'm Klansman Jaden's husband for 56 years. That's my claim to fame. Yes, I can change the dishwasher maybe, and maybe I can move it, but that's not my priority. No. Okay. This is the 11th year that Jade and I have held this fundraiser for CRI at Sailfish. Originally, as some of you know, this was a small ladies' night out, which has grown to this large community-wide event. We thank you and your generosity and support. As of today, we have been able to raise more than $2.5 million. And you deserve that applause. Cancer is the second leading cause of death in the United States, trailing only heart disease. To put things in some statistical context, there are 2 million new cases of cancer every year. 75% of them occur in people over the age of 55. The mortality rate from cancer has declined 34% over the past 30 years. However, cancer rates among women under 50 is now 82% higher than in men. Breast cancer under 50 is rising, and so is the incidence of pancreatic cancer. We have work to do. Fortunately, there are now more than 15 million survivors of cancer, and I am pleased to say that I am one of them. Cancer Research Institute was founded in 1953. Nobody knew anything about immunotherapy at that time. And now it's the global leader in supporting and coordinating research aimed at harvesting the immune system's power to conquer all cancers. Its scientific council director, Dr. James Allison, won the Nobel Prize in Medicine several years ago. Currently, 29 or more cancers are treatable with immunotherapy. Money raised by your generosity, now and in the past, has gone directly to supporting research labs. Over the years, we have funded 8 research labs researching breast, colon, lung, ovarian, glioblastoma, and lymphoma and leukemia. Currently, we support labs at Rockefeller University and Stanford, working on gene editing by engineering immune cells and the role of immune B cells in cancer. This is critical, basic research being done by dedicated and talented professionals. But you didn't come here this evening to hear from me. Over the past 2 years, Dr. Jill O'Donnell Tormey has spoken here and met many of you personally. Jill had been the CEO of CRI for 31 years. And this last August, she retired. I'm delighted to say that the new CEO, Dr. Alicia Zoe, is here with us today. Jane and I had the privilege to meet Alicia via Zoom last week and found her to be a dynamic, bright, informative, and enthusiastic advocate for CRI. It was easy for us to see why she was hired. She has a Bachelor of Science in Biology from MIT, a PhD in Biological and Biomedical Sciences from Harvard. She completed her postdoctoral research in cancer biology at the University of California in San Francisco. Her resume is on the table for those in front of you, for those who are interested. Please join me in welcoming to Sailfish Point, Dr. Alicia Zoe.
Good Good evening, everyone. It's a real honor and a pleasure to be with you all tonight. And thank you so much, Dick, for that amazing introduction. This is truly a special event, and I feel very honored to be here with you all. As Dick mentioned, my name is Alicia Joe. I am the incoming CEO for the Cancer Research Institute. As many of you know, I stepped into this role very recently in August, so I'm here for about 4 months. But of course, I'm succeeding the steps of Dr. Jill O'Donnell-Tormé, who led this organization fearlessly for 3 decades. And so there are very large shoes for me to fill, and I'm very excited to be taking on this amazing organization. So you've heard a little bit about me, but I'm a molecular biologist by training, and really the best way to describe me is that I'm a science nerd. I love to think about the way that biology interacts with human health and how we can solve problems, really starting from molecules and thinking about cells. My training started in breast cancer research, and I trained at institutions like MIT, Harvard, and UCSF. But my focus really was on oncogenes and how do we think about how oncogenes drive tumor growth, specifically in breast cancer and in triple-negative breast cancer, and that was the focus of my research. About 10 years ago, I left academia to actually join a cancer genomics startup called Color Health. And there, I was really focused on understanding the role of germline mutations in driving cancer predisposition, and how do you increase access to genetic testing to help individuals understand their inherited risk for cancer and empowering patients to get access to this type of life-saving diagnostics and hopefully therapy. I had the privilege to lead that organization as their chief science officer for almost 10 years and grow that organization to be able to bring this type of life-saving genetic testing to the hands of millions of patients. So now I'm excited to be taking on this new role as the CEO for the Cancer Research Institute. And I'm bringing together my experience from both the bench and industry to figure out how we drive innovation and maximize impact now in the seat of a nonprofit organization, really trying to continue to solve this problem, which is our fight against cancer. I really do want to take a moment to express my heartfelt gratitude for Jane and for Dick for hosting this remarkable event once again. As you guys have heard, this is our 11th year here at Sailfish. And what we've learned is that there's something very special when you have a set of individuals who feel driven to make an impact within their community. And I think Jane and Dick really are a testament to when an individual believes that they can have impact, how much they can bring a community together to make that impact. So I want to take a moment to celebrate and give a round of applause. I think their dedication is nothing short of extraordinary. And the fact that so many of you return year over year speaks volumes about the profound impact they've had on all of us here. Jane and Dick are the embodiment of what it means to turn personal passion into meaningful, far-reaching change. And we're all inspired by their unwavering commitment to making a difference. And in fact, this year, I'm incredibly proud to share that this event has raised almost $600,000 towards cancer research. And that does include an extraordinarily generous gift of $300,000 from the Florman Family Foundation, as well as generous contributions from many of you who are here tonight. And what that means is that our collective support for this event has raised over $2.5 million over the last 11 years. Give yourselves a round of applause. These funds have a direct and lasting impact, and it's particularly through our CRI postdoctoral fellowship program. Thanks to Jane and Dick and all of you here tonight, we've been able to fund 8 exceptional scientists, and they've already received that vital research support to move their careers and their research forward through the Dr. Keith Landsman Fellowship. I'm happy to share with you tonight that after this event, we will be naming 2 additional Landsman Fellows due to the support that we were able to raise in this event. So that brings our total of scientists supported through this event to 10 scientists. So this brings me to a very special part of this evening, which is to introduce someone who truly embodies the spirit and potential of CRI's mission. Many of you met Dr. Andrea Schiedinger last year at this event, and we're delighted to welcome her back to share an update on her work. Andrea is an exceptional scientist whose career has been closely intertwined with CRI. She was a CRI fellow during her postdoc, and then in 2019, she was named one of our 5 inaugural CRI Lloyd J. Old Stars. This is a distinction reserved for researchers whose work has the potential to dramatically advance the field. These stars, which are selected by our Scientific Advisory Council, represent the future leaders of cancer immunotherapy, and Andrea is already fulfilling that promise. Andrea's research at Memorial Sloan Kettering Cancer Center is pioneering. She's unraveling the complexities of T-cell behavior in cancer and autoimmunity, which are really 2 sides of the same coin. Her work is uncovering how tumor-specific CD8 T cells, the immune system's frontline soldiers against cancer, can be reactivated to overcome exhaustion and dysfunction. And this work holds the potential to revolutionize immunotherapy, making it more effective and accessible for patients. Andrea has been relentless in pushing the boundaries of what's possible. With CRI's support, her lab has uncovered 2 critical immune cell types that could transform cancer immunotherapy: CD4 T cells, which may help overcome tumor-induced CD8 T cell dysfunction, and stem T cells, which play a role in autoimmunity. Her team is now exploring how to engineer these types of cells to develop more effective cancer therapies. And these breakthroughs wouldn't be possible without the support of CRI, but donors like you who make this work a reality. So without further ado, please join me in welcoming Dr. Andrea Schiedinger to the stage and share her latest insights to inspire us with the possibilities ahead.
Hello, everybody. It is such an honor to be here again, the 2nd year in a row. And first of all, I want to thank Jane and Dick for having us, for having me. And yeah, some of you have seen me and speak last year, and I promised to come back with updates. I hope to fulfill that promise. Like Alicia said, I'm a tumor immunologist, and I just want to take 2 minutes to tell you my story, how I ended up in New York and why I'm a passionate scientist and a tumor immunologist. This is a German accent, so I'm German. I was an exchange student, came in 2001 to University of Chicago. Only for 6 months. The Germans said, you need to go to the Americans, to University of Chicago. There are these famous tumor immunologist scientists. You learn things and you come back. But I never returned, and they're probably still waiting for me. I loved the way how science was done at University of Chicago, driven by curiosity, by dedicated scientists, and just to be in for the science. And then after 6 years after I completed my PhD, I went to Seattle, because during my PhD I did a lot of basic science research. We used preclinical mouse models, we gave them tumors, and we asked the question, what is happening when you do immunotherapy? And things were working, but I felt like during University of Chicago, I lived in this bubble, in this mouse bubble, people call it, because you want to stay connected with the real problems in science, why so many therapies that we do in the laboratory actually fail when we translate them and we try them out in humans. And so that was the reason why I decided I want to go to Seattle, where there's another famous tumor immunologist, actually part of also of the CRI community and Scientific Advisory Board, Dr. Phil Greenberg. And so I was introduced into the problems that the doctors face day by day, why therapies don't work when you use the immune system to try to cure cancer. And so I learned a lot, and especially what I learned was to really work on the real questions. And after I completed my postdoc, Then I was recruited to Memorial Sloan Kettering Cancer Center, and in January 1, we just celebrated our 10th anniversary of the Schillinger Lab. So I would not stand here without the support of CRI. So Alicia said I was supported as a postdoctoral fellow in 2013, the critical years in a scientific career. And having this fellowship really allowed me to go after the questions and to be supported financially and to really, work on the things you dream of as a scientist. And then at Memorial Sloan Kettering, as Alicia said, I became, again, was supported by the CRI through the STAR Fellowship. It gives you 5 years of unrestricted funding to just go for the most bold and high-risk questions. So the funding situation in my field in biomedical sciences, you write grants, you go to the government, you try to convince them to give it to you, but by the time you finally get the money, there might be other things more important and so forth. So having this ability through CRI to just work on what you believe in and what you know, it is super high risk, but if you work out, it will be potentially a breakthrough that we can build on. So I got that award. It was $250K for 5 years, which is allowing us to do a lot. And so last year I introduced the project that we were pursuing. And so now I want to talk for 2 minutes about the science that CRI supported us and which we are really, really excited about. And we actually try to move this now into the clinic. And so over the last 20 years, you work with these preclinical mice in the laboratory and things work. But then you look at the clinical data from patients and you see this huge contrast that only so many few patients actually respond to when you use immunotherapy. And so we were really working hard and we said, why is this not working? We went to the whiteboard and we said, maybe we have to think outside of the box. So think about this, you and I, we have billions of immune cells. And those immune cells are getting created to protect you from infections on a daily basis. So when you go out and you get a virus or a bacteria, these billion of immune cells, and you have one for each virus and for a little thing on the surface of the virus, to recognize and to take over and eliminate the pathogen that invades you. So the theory in cancer immunotherapy was, well, we have a billion of cells. Let's look whether one of those billions of cells actually are specific for cancer cells. And so this is not new. We didn't cover this. This is fact and history for 50 years. You and I, we have immune cells, many of them, which in theory should recognize your cancer cells. And what people actually found was that those immune cells, yes, they really see the cancer cell. They have certain markers on their surface. We know exactly that they realize there's something growing that shouldn't be growing. But what is the mystery and the billion-dollar question in the field? Why do the immune cells not eliminate the cancer cell, but your virus and your bacteria? So this was the concept. So I took my team to the whiteboard and I said, you know what, this doesn't all make sense because sometimes the immune system actually works too good. So you and I, we have billions of immune cells, but guess what? A large proportion of those immune cells can actually, in theory, attack normal tissue. So, and that's called autoimmunity. So in autoimmunity, there are many diseases, such as type 1 diabetes. So type 1 diabetes is a disease where one of those billion immune cells suddenly decides and says, you know what, I'm going to the pancreas and I'm killing the beta cells. And that's how type 1 diabetes or diabetes forms. So we thought, why is this happening? Why can these immune cells go to normal tissue and wipe out an entire normal tissue, but what's foreign, like a cancer cell, cannot be eliminated? That's crazy. So through CRI, that was the question we proposed. We said, you know what, as a tumor immunologist, I need to understand why autoimmune cells go into the tissue and wipe out an entire tissue. And then once I know that information, I bring that information back into the immune cells against the cancer. Okay, so what we did over the last 5 years, we actually looked at autoimmunity. And we asked the question, how is it possible that over years your immune system attacks all these normal cells? And what we found was a so-called stem cell. So they are very, very, very special cells. There's only one of them. And they have a very, very unique repertoire of action in them. And they shoot every day thousands of these immune cells that then travel to the normal tissue and cause autoimmunity. So we, last year, I was talking about it, identified that so-called stem cell, that one single cell in your body that is responsible for eliminating pretty much an organ. And so what we then were working really hard over the last year was to identify what makes that one single cell so special. So we digged into what is called the nucleus. That's where your DNA is wrapped around, like these long miles of information of DNA. And we asked the question, what is so unique to that one cell? And can we engineer potentially that one cell for the cancer patients? And so with a lot of efforts and a lot of hard work, we finally identified, we think, this one factor that makes that stem cell an autoimmune stem cell. And what we have now done over the last month is we cloned that one factor, we multiplied it so many times, we put it in immune cells that are against cancer, and we gave it to the mice, and we asked the question, can you now make so many more cells that attack the cancer? And the early data looks really, really exciting. So we increase the number of these cancer-fighting immune cells. They go into the tissue in mouse models, but it is one of the most exciting data that I personally have seen so far. Started with the CRI fellowship. I'm a basic scientist. I'm a pharmacologist, trained as a pharmacologist, but I don't see patients. And as a basic scientist, you sometimes wake up and you wonder yourself, or you ask yourself and you wonder, well, will my science ever have an impact? And will it actually change something? Or is it just curiosity research and driving basic science forward? And maybe 20 years ago, I was this excited science geek, science nerd, who was just excited of doing science in the laboratory and so forth. But the more older you get, and I'm now kind of old, I want to have an impact. So only working on the questions that are really, really changing lives. And when Jane actually said, turn on the candle and think of the loved ones you have lost, unfortunately, yeah, I think we all have too many of those memories. So the inspiration through CRI comes also from the people who lead CRI. And there are many institutions and organizations who support cancer research for specific cancers and so forth. But what makes Cancer Research Institute so special is, I think, to really look at the science. Politics aside, you just read the proposal, you say, is this feasible? Is this high risk? Potentially high reward? And CRI goes after those questions and those people. And Jim Allison, Alicia actually mentioned, who got the Nobel Prize, every time when I see him, I go up to him and say, Jim, you know what? Every time I have my students and they are kind of depressed or down, I remind them of your story, because Jim Allison was also a basic scientist. And for decades, people really you do basic science as a basic scientist. And he stuck to his gun. He believed in what he was doing. And now he has so much impact of curing long-term cancer patients with his immunotherapy that he developed. And rightfully, he got the Nobel Prize a few years for that. So, I don't know, basic science is at the heart of what we will have as cure potentially in 20, 30 years. And that's why it is so important that we continue to fund the basic science. And yeah, that's why I'm here, and I want to wholeheartedly thank you for your support over the years, because in the end, you are the reason that I got the fellowship, and ultimately my trainees potentially are supported by CRI, so I want to thank you for that.
Okay, so there's no confusion. This is the deal this year. There is a question and answer period if you have a more general question you would like to ask to Alicia or whomever on this committee. So I will ask Doug to, pass the mic. And then when that is completed, I want you to understand that we are all eating together, okay? Here, those men are welcome to join us because this has become much bigger than just a ladies' night out. And we will have a DJ, and let's celebrate what you, not us, what you have accomplished. Thank you.
So a show of hands, anyone who has a question?
I do. I have a question for Doctor. What is the impact of artificial intelligence on the future of your research?
I love this question. So I think the interesting thing that's happened for us as a society is we've seen how computation has really taken every field to the next level. And what we know now is that we can ask questions much more quickly when we have access to the right data. And a computer can come up with and test thousands, if not tens of thousands of hypotheses in milliseconds, right? And whereas before we needed scientists to really think through every single hypothesis, now we have the ability to actually use artificial intelligence to help us do this initial piece of the scientific process. And so the way that I describe it is that we are moving from a hypothesis first world to a data first world, and that means that we actually let the data lead us to the hypothesis, and then the bench scientists are using that data to drive how they do their bench science. So I think that AI has a huge potential to really revolutionize the speed at which we can ask questions and the speed at which we can test hypotheses first in silico, so in a computer, before we even pick up any pipettes. Now, the only way for that to be really applicable in life sciences is for us to have the right data to feed it. So the thing about AI is that it's garbage in, garbage out. And so one of the areas that CRI is very focused on now is how do we generate the right data sets that's going to help us ask the right questions and give the right sort of foundation to our CRI scientists to be able to use AI and help them accelerate their work. So this is actually an area of real focus, and we are actually going to be launching a data program in the coming months exactly focused on this. Great question. Other questions?
How old do you have to be not to worry about cancer anymore if you haven't had any signs of cancer?
This is a really good question. So the way we have to think about cancer is ultimately cancer actually is a disease that starts with normal cells. So cancers all start with a normal cell in your body accumulating some sets of mutations that eventually leads it to proliferate in a way that's completely uncontrolled. And then what happens is your body loses control of its ability to kill those cancer cells, and then what happens is that a tumor might grow. So what we know then is that ultimately it's sort of this math problem. Over the course of your lifetime, your cells, your normal cells, are going to start to accumulate these mutations. That starts from birth. Now, most of these mutations can be completely benign. Most of these mutations have no actual effect on those normal cells. At some point, it's possible that enough hits happen on the same normal cell that it becomes a cancer cell, and that cancer cell starts to grow out of control. And now what we know is that that cancer cell has to overcome actually your immune response. So there's also these checks in place where your immune response is going to try to stop that cancer from growing, and then the cancer has to find a way to overcome that. What we know then is because this is this sort of constant process of cells accumulating mutations, it is true that over the course of your lifetime, as you live longer, the likelihood of cancer happening becomes higher simply because it's an odds game. So unfortunately, that means you can never sort of not be afraid of cancer, but we also have a lot of great screening tools now for most of the common cancers. And what that means is that you play an active role in making sure that you can get earlier diagnoses. Because what we know is that when it comes to all these survival statistics, where we know that we are seeing much better survival rates, that's actually often due to folks going in for their screenings, getting their mammograms, their colonoscopies. Now there are some of these blood-based tests. This is the active role you can play to help catch cancer earlier, because we are developing therapies that can help you then. So it is important to stay vigilant. And unfortunately, there's not an expiration date on that vigilance. James.
Good afternoon. Thank you for your presentation. I have a question over here.
Oh, hi.
Hi. Recent stories have indicated that younger people are increasingly incurring cancer.
Yeah.
Do you have a theory on why and how we can perhaps prevent that?
Yeah, this is a really good question. So there's several different cancer areas where we've seen this to be true. The most recent ACS Facts and Figures report that was just released about 2 weeks ago shows us that in the last year, 2024, we've seen an increase in earlier onset breast cancer. And we're talking about breast cancer that occurs earlier than the age of 50. And then for the first time, we're seeing also in pancreatic cancer, we are seeing an onset at an earlier age. The previous Facts and Figures report from 2024, which looked back at 2023, also indicated this was a trend for colorectal cancer. So now we know we have 3 different cancer types where for the first time in decades, we're actually seeing a higher incidence in individuals under the age of 50 than individuals, it still continues to decrease in individuals over the age of 50, but somehow in individuals under the age of 50, we're seeing an increase. So I would say there's a couple of different things to look at here, and there's many scientists who are now trying to understand what is the root cause of this trend. And so we have to really think about what are the things that have changed in the last several decades that might have increased our risk for these types of cancers, and that's ultimately the root of the question. There's been several different hypotheses here, and I think we don't yet have a clear answer, but in terms of leading theories, we know that potentially it has to do with diet and obesity. We know that in addition to having an increase in these cancers, we are seeing also the rise of the obesity epidemic also coincides with this. And along with this is the increased ultra-processed foods and diets that folks are eating, so that's one area of exploration. A second area that folks have been looking at is the consumption of alcohol and whether that might be related. And then the third, actually, I think that's interesting is there's a set of research going into understanding whether microplastics may have had an effect on incidence of cancer. We know that microplastics became very popular in the last several years. I think everybody remembers in the 80s and 90s, everything was put in styrofoam, and not as much anymore. But these, of course, have long-standing effects. Now, we don't really know what the answer is, but these are some of the leading theories, and so they are often linked to lifestyle and behavioral change. Jane, you had a question, yes?
I actually was going to ask this question.
Okay, great. Yeah, it's a very good question. I think this is an area where there's a lot of active research, and I think this is where it becomes really, really important for folks to think about earlier detection and screening. I think as many of you know, it can be very hard to get to that point where you activate and say, okay, now I need to start getting my mammograms every year, or now I need to start going in for my colonoscopies. It's not exactly the most fun exercise to go and do those screenings, but we have this issue where we're seeing younger individuals, I'm talking about folks in their 40s, who are due at the age of 45 for their first colonoscopy, and they put it off. And they say, I just turned 45, it's not a big deal. It used to be 50, so is it really a big deal if I get screened today versus if I get screened tomorrow? And that that procrastination unfortunately pushes them out. And then now they go from thinking they were gonna get screened at 45 to waiting until they're 48. And then this is where we end up with this issue. So what's really important is this awareness, but also the activation to get screened, because this is a real problem where folks have all the best intentions, but they have that, it's really hard to get over that hump of saying, yes, I'm gonna go into the doctor and take an active role in my health. Other questions?
Going in the back.
Yes.
Hi, thank you very much. I'm from San Francisco too, so
Fantastic.
go. One of the questions I really want to ask, that seems to be what everyone's doing these days, is scanning your
Yeah.
body.
Yeah. Mhm.
What do you think of that as a prevention tool that people are doing?
Yeah.
recently?
Great question. So, so there's been a rise of, I would say, two technologies that have become very promising and become more popular over the last, I would say, 2 or 3 years. One is these full body scans, full body MRIs, full body CTs. There's a company out there called Prenovo that's doing this and is sort of having these full body scans annually. The other technology that has become more prevalent in the last several years is this technology known as liquid biopsy or multi-cancer early detection, where you're using a blood sample to try to detect cancer at an earlier stage. I think both of these technologies are incredibly promising when it comes to potentially helping us diagnose and detect cancers at an earlier stage. They do come with this pros and cons. When I think about talking to folks about science, sometimes people think that we have these eureka moments in the lab where we know exactly what the answer is. And the reality is that the process of doing science, I think of it as sort of scales. And every time you get a piece of data, you put one pebble on one side of the scale. And at some point, you get enough pebbles on one side that you decide this is the prevailing hypothesis, right? And so when it comes to things like full body scans, as well as these blood-based tests, what we know is that they can detect more signal, so that ultimately means we're seeing more data rather than not seeing data at all. The issue can be then whether or not these data are informative or not. Are there false positives? So are you going to be in a scenario where you detect something on a scan that you otherwise wouldn't have gotten, and now you have to go and do that follow-up to get that follow-up diagnostic test to confirm whether that is cancer. So this becomes an individual sort of calculus for every patient. And the question you have to ask yourself is, am I prepared to receive a positive result that requires a follow-up diagnostic, knowing that some of these tests are actually tuned to be more sensitive, meaning that for some of these tests, actually about 50% of those positives are false positives, but 50% of those positives might result in a diagnosis of cancer. Are you able to handle that sort of uncertainty? And if so, then these might be the right test for you. And if not, it's important to know that before you take that test. Otherwise, it can really cause a lot of stress. Yeah. This is a question about whether plant-based nutrition has any role in cancer prevention. So yes, in that what we know for sure, and has been put out by the WHO as well as by the ACS, that we know consuming red meat as well as processed meat, these both are associated with colorectal cancer, and this is now part of the WHO recommendations. It's in the ACS as well, and so what we know then is moving to a plant-based diet, especially reducing consumption of red meat and processed meats, can really make a difference in terms of colorectal cancer risk. Another big category here for folks to be aware of is smoked meats. So as you can imagine, if you took a piece of meat and you stuck it into a smoker and then just bombarded it for hours, it's the same reason why we don't encourage smoking for your lungs. We don't encourage you to eat that piece of meat that's been sitting in that smoke for that many hours. So it's all about having everything in sort of moderation, but you can understand sort of how those causations are actually linked. So I'm not saying don't have your brisket, but maybe don't have it every Sunday and save it for some special occasions. Great question. I just ruined everybody's Sunday, I just realized. Other questions? Yes.
Well, wait, it's 4th and 15th.
Yes. Andrea. Oh, yeah. The question is for you about sort of what you hope to see in terms of cancer therapy advances in the next 20 to 30 years. You mentioned that you think there was promise there.
Yeah, so what I would like to see is that we might not be able to cure every single cancer, but at least we might be able to understand what the reasons are for different type of cancers not to work. So in cancer, there are two type of cancers, right? There are the type of cancers that grow, and the immune cells, they find their way in, but then they don't work. There is a large number of cancers where the immune cells don't even find the way into the cancer. And so we scientists call them hot or cold. So hot tumors are the ones where your immune cells, they know there's something growing, they go on, and that has been my research over the last 20 years to figure out, okay, they find their way in, but they don't do anything, right? Like, for example, in the lung when you have an infection and they get rid of the virus. So through this autoimmunity research, what we have been seeing is the reason why the immune cells do not go to the cancer site. So, which I think this is a super huge opportunity, because now what we are doing, we are saying, okay, you're an immune cell, you're specific for my cancer, and every single tissue and organ in your body has so-called headquarters, okay, where all the immune cells are coming together. And that's called a lymph node. So when you're sick, your lymph nodes swell up, right? But only specific for your specific tissue and organ. So what happens in these cold tumors, the immune cells that should go in, they get stuck in the lymph node. And so what we have been now trying to understand is, A, why do they get stuck? And why are they not, what is wrong with them when we zoom into them? So we compared that one single cell that I talked about, that autoimmune stem cell, and we said, you know what, this one single cell sits in the lymph node, in the pancreatic lymph node, and does shoot out every single day thousands of these T cells, immune cells, that then go to the pancreas and kill. When we then compared that to pancreatic cancer, we find in the same lymph node, they are sitting there, but they don't move, and they don't produce these thousands of cells. And so what I think in the future, we have to understand each cancer comes with its own problem. This was basically the example, right? In some, you have the immune cells going in, and in some, you don't. And if we understand what are the reasons for each cancer, why things don't work, hopefully in 20 and 30 years, we can then really adjust immunotherapy specific for each cancer. Because pancreatic cancer, glioblastoma, lung cancer, I think they all come with their own set of problems. And if we need, I think, to really identify these tissue-specific or cancer-specific problems and make therapy for these type of specific cancers that work.
Remind you, Doug showed me how to do this. I just want to remind you that our wonderful, wonderful, talented doctors will be here all evening long. So feel free to go up and introduce yourself, ask any personal question you may want. And now comes dinner and celebration and anything else you want. Thank you.
So wonderful.